So, welcome everybody to the meetup number 103 of the Dutch Clojure meetup. We are here at Lunatech, and we are here after, I think, 5 to 6 years since last time. Beautiful office, beautiful city, and we are going to have a beautiful agenda as well. We have 2 talks on the agenda. First one will be from Christian from Germany, coming to talk about Datahike and Datalog and queries. And the second one, straight from South Korea, we're going to have Baruch to talk with us about the StarCraft and how to do Clojure stuff with it. So I'm going to give the stage to the first speaker now. Enjoy.
I will talk about Datahike today, which is a recent project. First of all, I want to say that I have not gone through all the slides in one run, so I don't have like a fixed time budget. I can try to match any. I think I have 45 minutes officially. So, right. So I will try to stick to this, but yeah, I mean, if you have any kind of questions or interruptions, I think we are flexible enough probably to interrupt, and I will directly answer, because this is what I like about the meetup format, that it's fairly direct and open, and it's way less formal than having like an official talk in place. So first of all, about me, I don't want to talk too much about me, but I've just done my master thesis in machine learning and on computer vision tasks. So I will pursue this. I was not sure about doing a PhD like a year ago, but it's pretty fascinating, and I will work on the probabilistic programming language, Anglican, which happens to be in Clojure actually, and it's a pretty cool continuation passing style compiler, and doing some interesting statistical stuff. And this will be at UBC in Vancouver. So for me, this will be like a big move in the next month going there. I have previously worked mostly in Clojure on the replicative libraries. They are not crazily famous, but there are some useful things in there, I think, and it has proven an interesting way to recombine them over the time from what I've learned to build database solutions. So this is not directly tied to the machine learning, except for the fact that I believe that you need to be able to manage large amounts of data and should like have possibilities to deal with data to do analysis. Like, there is no good machine learning without good data collection and management. I also do consulting. I've started a company with a friend, which is called Lambda Forge. We are situated in Heidelberg. And yeah, it's great fun. Actually, there is enough opportunity to do, or you can, if you are smart, you find a way to use Clojure and make money with that, which is great. I think this was not often the case for Lisp programmers, that it was actually possible. So I've heard this before in the discussions that in the beginning I think most people just did it out of enthusiasm, but I think it's very practical language and pragmatic environment. So first of all, this is the rough outline of the talk. I will give a brief motivation. I think you will have, if you have used a Datomic or a Datalog database, you might have other motivations, and you know about this already. I will just tell about my angle to Datahike. Then I will talk about what Datahike is in terms of prior work. So I will not go through all the details, because this would obviously be too much for 45 minutes, I would say. And there is really good material, and it's also not my work, so I would just like claiming to present something from people who have already partially presented it. I will talk a little bit about Datalog, but only briefly as like the general concept, and then I will try to give you a live coding example that we recently used this for invoicing. So I really like to take great ideas and use them for stupid, simple problems, because then you know that it's actually a good idea if it's also working in these small kind of setups. So my motivation in the database space, I came, I'm coming from an eventually consistent, or more precisely causally consistent context, which is a system that allows multiple writers and does conflict resolution on object basis. So this is a conflict-free replicated data type, or confluent, or there are different variants for the C. And these are data types that basically allow you to edit the same piece of data in multiple places without coordination. And you can imagine that this is useful in many cases. If you want to do a most simple example is offline edits on a mobile phone. If you want to use it to directly, even if you are online but your connection is lossy or laggy or in any way, you can give the user a faster experience. So in this case, you would do optimistic updates and things that are related and often can directly be translated in these kind of data types. So many of you will have just, even if you have never heard about this, I think some basics of it are intuitive. It's harder to get it right though. I mean, you often are making assumptions that then will not hold if you try to do transactions, for instance, in your system, and later on the system turns out to be in a different state or has been in a different state. The problem with CRDTs that I have implemented them in Replicative, at least some of them, and this has worked as a system where you could build front-end applications in React Native. You could also build a Clojure streaming solution where you could stream different types of data types, for instance, a Git-like data type, or a data type that has a map semantics that also allows removal of items into, for instance, something like Datomic or some arbitrary backend database. So the idea was just to do the kind of write coordination and deal with the distributed part of the system, but still give you like the normal databases and put them behind this kind of write semantics, assuming that you then know what kind of restrictions you have. I mean, you cannot express everything. So there are still some burdens if you want to use this off-the-shelf database. But I don't want to talk about this here too much. I think the problem, or one problem for me conceptually, is that if you want to combine CRDTs, it's not intuitive how the conflict resolutions exactly composes, and especially I'm working in Clojure, and I worked with Datalog in the front end in form of Datascript and Datomic in the back end. And it's like a really superior form of technology, I would argue, compared to objects, relational kind of mapping. So in this case, you would have objects that are properly defined in a concurrent setting, but you still have objects that you are composing and that are all mutable, concurrently editable, and that then can compose a more complicated application. But it's still not as declarative and easy to recompose them, for example, or reaggregate them. So this is why I'm interested in Datalog, because I think it's a better trade-off. And the most interesting thing in following Rich Hickey in a way, or it's like better to constrain yourself. So Datalog is a Turing incomplete language, so you deliberately choose a language that's fitting for your data tasks, and you hope that in the longer run you get a better trade-offs if you want to do the conflict resolution, for example. So this is something where I do not have an answer for yet, but I'm currently looking into this. So Datahike itself does not solve the CRDT part, but I'm interested in Datalog because I want to go back to this point. So this is really great to see on the beamer, I think. Yeah, so I will just briefly describe Datalog. I don't know, who of you knows Datalog in some form or another? Like a third, maybe. Okay, so Datalog is a subset of Prolog, which is a logic programming language, which is basically you describe what you would like to have in a declarative way, and it's trying to find a solution. And what you all know is basically SQL that is doing the same thing. So you describe, in this case, relations between typically a tabular structure, and then the query engine is figuring out an efficient way for you to retrieve this data. It's guaranteed to terminate, and it has a well-defined semantics in the sense that you can compose expressions of the language and it still yields you valid expressions. You can, in theory, do recursion in SQL, but I think few people ever do because it's very elaborate and complicated. It's not a beautiful language to build complicated logic expressions in. So the cool thing is that you do not see here, but you will be able to see this later, I think, in Emacs, is that in Datalog itself, you do an implicit joining, which already eliminates a lot of the outer joins and where in kind of semantics in SQL. It's just a lot more terse. So what you should see here is I introduce a logic variable e that I'm already also querying, but could also be implicit in the context. And I'm just saying, okay, it should have the name attribute of this user 3 299. This will be from the later, will pop up later again. Right, so I want to talk about Datahike now, and Datahike is nothing more than approximately, at least at the moment, Datascript plus the Hitchhiker Tree. That's also where the name comes from. It's not really creative, but it was not taken, and it was in that sense at least exotic in a way. So yeah, right. So I mean, it was actually Datahike itself. I knew that it was possible because I had a look at the Datascript codebase, and I knew that the database interface was just in B+ tree. And I knew that from last year working on the Hitchhiker tree, that is just a nice data structure, that it basically provides the same kind of data structure, but I was not sure whether it's actually pluggable. So around Christmas or New Year, I sat down and just tried to hack it together as quickly as I could, because I had few amount of time, and then it figured out that I had one stupid bug that like totally killed the performance, because I was linearly scanning the index all the time, and it took me like 2 weeks to figure out that I should have used a take while and not a filter argument while scanning over the whole index. It was really like thought error in a stupid way. But anyway, it turned out to be very well working. So the performance is nice. I will talk about this in a moment. But first I will go over the two building blocks. So Datascript is, if you don't know it, who of you knows Datascript? Okay, so roughly the same kind of people who know Datalog. Yeah, so Datascript is a really nice, compact implementation of the Datomic style Datalog in Clojure and ClojureScript. So it runs both in your backend and in the front end, with the only caveat that it is only in memory. So whenever you have a data set that's too large, or when you want to actually replay on the next session the same kind of data, you have to do the storage part yourself. And you have to have the whole data set in memory all the time to be able to query it, which is okay, I guess, for most simple use cases, or for many also non-trivial use cases. It has benefits to have this, but it's also obviously not like, I would not consider this like a usable backend database, at least for my purposes. The convenience is not the same. So it's very mature, so I didn't have to worry about a large test suite, about a lot of users that have used it, tons of issues fixed. So I know that this part of the code base is safe. I just reuse this, and I can just use these tests, and that's what I did. I just changed the indexes at the same time. I had the new and the old index, and was looking at the interface points where differences in the index behavior would show up with the new kind of index, and fix them gradually until all tests would pass, and I would not see any difference in the behavior of the index data structure. So it was a fairly surgical way to be able to just fix these interfaces and not like had to deal. I don't even understand like all of Datascript's code base now, even now. So I still want to go there, but it was not necessary, and it was really a big relief, and also a testament, I think, to the functional abstractions and the way that you can cleanly build nice, complicated systems in a functional language. So yeah, the next property that's pretty interesting in our test is it has a faster in-memory, at least, query performance than Datomic. It's not crazily faster, and it definitely will. It's like, do not take this benchmark as any kind of serious, I mean, benchmark is really hard, but seeing it in simple benchmarks to perform that well is also motivating that this is a viable database approach from the beginning. And it supports like a lot of the more elaborate Datomic features, especially pull expressions, which are really handy, and I will show them in the end. It also supports transactor functions, which can reject if the transaction does not fulfill the necessary invariants that you want to have in your data base. So they run basically in a transactional context, and they are just a closure function. You can call them basically by extending the language that the transactor understands, and then it calls your custom functions. So it's really flexible. All of this also runs completely in your in-memory context. So you can just call an arbitrary closure function in your query context. It's the same for Datomic and for Datascript, and it's really nice. So you can take another database if you like to, and inside of your logic query you can join it with Datomic, which is, it's not using the same kind of index indexes, so it can get inefficient if you're doing this manually, because it then has to do scans and has to realign this. So it depends on how you do it. I mean, it's not like a free lunch thing, but it's really powerful. So I did this once, for example, to just access a training history of a machine learning model, which was many gigabytes of just floating point numbers bunched in an HDF5 file on disk. And then you can just, in the query engine, like ask that it would give you, or it could select like every 100th element in the language of the tensor database. So, I just mean it's like extremely flexible compared to SQL, because it runs in your process, in your language, integrated on the client side, and also the query in Datomic. Like, I won't go too much into the Datomic design, but I can really recommend looking into it, because the query engine reading is completely decoupled from writing. So everybody can read, and you will not block any kind of writer. So it's really scalable, readable terms, a really scalable database. Okay, and the schemas, at least right now in Datahike, is the same. The schemas in Datascript compared to Datomic do not have to be complete, so you do not have to list all the attributes that you're adding to the database and fully specify the schema, but you have a more like NoSQL kind of thing, where you could also just dump entities into the database at the price that you have a higher overhead of the attribute names. The storage of them is not just an integer or a long number, but it's a string of the attribute name. Okay, the Hitchhiker tree. Who of you knows the B+ tree? Okay, so B+ tree is a balanced data structure. That's like the best, provably the best data structure that you can use if you want to retrieve data from a storage medium, because it's had logarithmic access. So it's branching on each level on some factor that's determining your logarithm, and then you have to go a log n levels until you reach the leaf nodes of your tree, and this is in the sense optimal if you do not know anything more than the uniform. If you assume a uniform distribution of your data points, if you know that you access them in many of them much more often, then in theory that's also what you then practically do, is you cache them and you try to introduce some additional. You introduce basically caching, but yeah, that's in general purpose. And it combines the B+ tree with an append log inside of the tree structure. And I will show you a graphic of this in a moment. But the idea is that this allows you to choose for your particular application an optimal trade-off. So you can make the append log part bigger or the balanced tree part bigger, depending on whether you want to have better read performance or better write performance. And then you go somewhere that's amortized, so it's not possible to have like exactly these O numbers. So I've cheated a little bit, because I didn't want to go through the exact math to show this, but it's shown in the Hitchhiker tree, at least like with examples, also not with the math. But I think there are some documents, or there's one document at least in the Hitchhiker tree repository that goes into more detail. One point is that the Hitchhiker tree itself is an implementation, and at the same time the description of this data structure. So far at least, I have not seen this data structure. I mean, there are fractal trees and fractal data structures, but I think it's very specific, and it's like an invention and a documentation of this implementation at the same time from David Greenberg. Actually, he has done this and presented it at Strange2. I have the link in the final slides for the references. It also, that's just like for convenience, but it's really important that it supports batching. So you can just operate on it, and then you flush it when you need it, and then only you will do the I/O. So if you are transacting, and you get a lot of pressure, you can bundle transactions and then flush them to disk in aggregates, which allows you to go to the threshold where you are actually as fast as you can possibly write, even if the granularity of the transactions that are coming in is finer than what is too fine and would not allow you to achieve this performance. That's not implemented in Datahike yet to exploit this. So I don't know if you can see this. I think can you see this? So this is okay. So great. Like the left side is one Hitchhiker tree, where I have inserted the numbers actually from 1 to 9. I think there is 0? No, there's no 0. I thought it would start with 0. But yeah, anyway, from 1 to 9, you can see this in the leaf nodes here. So you see that they are just sorted, and there are some, the inserts were shuffled to make it not trivial. I mean, if you insert in the sorted order, it's like, I mean, you will hit typical behavior of the tree and it will be boring. So in this case, to create some interesting structure, I've done this. So you see here that they are sorted. There is the 5 missing, and the 2 is missing, and the 1 is missing, and they are still up there. And what you see here is the append log. This is like the same graph with visualization. I've just decoded this of the original presentation that David Greenberg gave at Strange Loop. He also used this. So this is what you see here is the append log. These are the range splits. So everything that's bigger than 6 goes to right, and everything smaller or equal to it will be in this segment. So you keep, like, if you come down from somewhere and you want to know where you have to go further down, you basically walk down these split markers in the node, and then you go to the next leaf node. This is like the B+ tree behavior, and here is the append log. Now, if I introduce into this, and these numbers, by the way, they are Merkle hashes. So the interesting property is it's a persistent data structure. So you can actually lay this out as an immutable, content addressable data structure in an arbitrary distributed system, and address it just by its Merkle hashes. And in this case, I've just introduced another 10 numbers. So the 19 is still up here, so we go till up 18 here. And you see that I have a branching factor of 3, so there has to be at least 3 in all the nodes, which is the case. And in this case here, I'm doing structural sharing. So this 9 is still pointing to the same root node. So although this is a new tree, you have the Clojure persistent data structure semantics on disk, and you have still the flushing. So 19 has only triggered a write event on the root node. It has not, for inserting, it does not have to go all down there. So what it will do on inserts, it will just go into a node, look whether there's still space. So here I think the space for the append log is a free parameter, but is like 3. If it's more than 3, you will flush to the next level. And then what you're doing, so one open question that's also addressed in the talk of David Greenberg, so you can also watch this. But one question that you have is, okay, but if I'm doing a query and I'm missing these append log items there, I mean, I have to project them back down to have the B+ tree kind of semantics. Because when you are writing, save the time and just write them in some node, then you have later, if you look up in some root node, you have to take them with you. And this is like the hitchhiking. So you take these guys that are standing there in these nodes still and are not really projected into the leaf nodes yet. You take them with you, and then you are basically doing the hitchhiking in the Hitchhiker Tree. And I think it's pretty amazing. I mean, when I learned about the B+ tree, I was somehow like lazily assuming like this is optimal and that's what all the database people are doing, so that's what I would have to do. And then amazingly, when I started to look into persistent, durable data structures, David Greenberg came out with this, and I thought, like, this is absolutely perfect. Because it's also, if you think about it, if you have a database, it's like you can do a lot of inserts. Just normally you would have a log, an append log, just to keep all the data, and then you would, at a point later, push this append log into your B+ tree at some point. So you are not writing all the time to the tree because it's not fast enough, and you want to capture the data and transact it when it's arriving in your system. And this data structure is naturally like solving this problem for you. So you don't have to do this additional transactor log playback coordination thing. All these parts are conveniently covered in a reasonable formalism. Yeah, so just, I promised this in the beginning. I've said it's a simple baseline benchmark, so it's not like, I'm not claiming crazy like benchmark. It's not a sales pitch for the database, But it's interesting to see that, well, so there are 100K entries in the database. It's not extremely much, but it's large enough to at least be of a reasonable size. And oh yeah, I just have one query here. So this was from my colleague and a friend of mine who did the initial benchmarks in February when this worked. So this is basically running the same query that you've seen before, this find, this Datomic Datalog syntax. And it's running the same query with a criterion benchmark on the three databases that have a similar semantics, like Datomic, Datahike, and Datascript. And in this case, it was Datahike is like almost as fast as Datomic. It's still a little bit slower, but I mean, it's without doing a ton of crazy optimizations. I mean, I've worked mostly on the Datahike, on the Hitchhiker Tree, and tried to make it faster or figure out whether there are some problems in there, but I have not done anything too crazy yet. And Datascript, you can see, like, if you do it just in memory, its B+tree implementation is really fast, which is also okay in a sense because Datomic is doing a lot more. It's doing connection management, you have to go through, talk to a transactor. I mean, it's a big penalty in the query part that you still have to pay, but I think, I mean, these are milliseconds for, well, I guess it was not this query, it was a more complicated query, so I'm sorry about this. But this was the kind of benchmarking setup. Because for the simpler queries, it's just like maybe a millisecond or two, or it's a really small number. So it's reasonable for a production environment. That's all what I want to say. It's like, is this working? Okay. So finally, like a practical example. Okay, you would in this case just import. So one thing that I did to make it usable is I covered, the Datascript already covers a part of the Datomic API in JavaScript terms, so it has a transact function that has a similar semantics, a query function, entity IDs. It's behaving very similarly, but it has not the durability baked in. So I have basically created a new API namespace that is covering for convenience, because we are at the company using Datomic in some consulting cases and have used it a few times. So it would be very reasonable if you had a similar API, so you can just swap it in and out. Because this is a database that is still very young, and you would not necessarily put it into a very serious environment, and it's not replicated. You cannot talk to it over the network and so on. On the other hand, it's much easier. It's just a library that you load. You don't have to deploy it. You don't have license issues and so on. It's way leaner in its appeal. And it's also transparent. I mean, it's interesting for me to see what's going on in it. I cannot look into the Datomic really, which personally I find sad in a sense. Yeah, I mean, it's like a really interesting database, and I think you can do a lot more with this kind of technology than what Datomic is just doing. I mean, it's great what it's doing, but it's very focused on solving the startup backend scalability issue, I would say, or big company backend scalability issue, but it's not really, it can be recomposed in many ways. So anyway, we have a URI scheme which is similar to Datomic. It's very simple. So that at the moment there's a memory store backend, a file backend, and a LevelDB backend. It would be totally reasonable and pretty amazing to integrate the Hitchhiker Tree's Redis backend, because this would allow you to write with memory speed and still have snapshots in a few seconds time, because Redis can give this to you. You just have to be able to have enough memory for this in the case, but I think this would be cool, something that Datomic itself cannot provide. So I just would have to, it's maybe 50 lines of code or 20 lines of code, I don't know, it's just adding it. So this is just the schema of Datascript. So it's just the same API. In this case, I have not implemented yet the Datomic type of schema, which is committed to the database itself. So schema is data, and you can query it, and you can join it, and it's pretty interesting. But here it's very simplistic. It's just this hash map. And you just describe the type of, the part of the data that you are actually really interested in. So here we have, for this invoicing task that I was recently working on, we have something like task groups, which are subsections in a sense. Each offer that can later be invoiced has several task groups. And here you can see it's a reference type, which is helpful for the pull expressions that we will see in a moment. And then here you can do some identity declarations where you say, okay, this is just a cardinality 1, and then you can use this in a special syntax to reference items. If it's unique and it's a qualifier for an entity, then you can conveniently use it when you are transacting. Right, and we have a customer name, so I have just created this schema. So here I can delete the old database and I will recreate it. And then this is like, the connection is actually just an atom that has a map in it. So one thing that's also I think is nice is you can just look into this if you like to. It's fairly transparent. It's not perfectly implemented yet, but I mean it's more like an open source project. It's also not financed in any way so far. So yeah, this is like if you transact, you basically just do an in-memory transaction on an atom. We log on this, so in this scope, in this machine, it's safe to do this, and then we write into the I/O in the log scope. So you are not able to interleave with two write operations at the same time. Like a very simple implementation, but it does the trick. Right, and here we are adding two entities. These are two customers in this case. So I've just like made them up. In this case, so these are just what you would expect to put in there somehow, some strings, some attributes. And here you can see, if you don't know Datomic, this is the way to in your environment, declare a temporary unique identifier that you can use to reference to the same thing before you dispatch it to the database, and it will give it an internal unique identifier. Because you're not working yet in a transactional context, it will have to resolve this later. Okay, so let's transact this. Okay, so this is just returning future. And then we can here retrieve again the entity IDs. And you see I'm querying for the logic variable E, which is represented by its ID. And for the customer name, which is ON, it does make sense, it should be CN. Or it's like free to choose, and then you get a result set of your data. It's like really typical database kind of thing. Okay. So here I'm adding different items that I would like to invoice for. So they are different tasks where you would say, okay, I have a certain amount for a certain effort, I have an hourly price, I have a price unit, so you can be very declarative. You would like to have, at least we would like to have this in a database that we can easily use, and that in this case also not proprietary. So it's nice for us that we just have this database available in this case and can keep the data. So we just add this basically as a nested map, and then we can again retrieve here, okay, we have now an offer with the ID 6 and the name adjustments in Q1 2018. We can also ask for the, so here you can see for the first time a pull expression, so you can use this also in the query language itself, and you can pull out from the task group everything that matches a certain task group name. So in this case, you're just, by using the task group name attribute, you're just selecting task groups, so you automatically are pulling them out, and it's more a hash map-like feeling, which would be more, I guess, NoSQL or a document database-like. Otherwise, I would have to write down for each attribute a query part, pull out each of the logic variables, and put them back into a map. So this is just convenient that you can get it out again. So, and the cool thing is, here I can do this nested. So I'm not even using Datalog right now, I'm just like recursively pulling out the nested data structure that I've just put in there. And I will now put this into a PDF, and this is not directly related. So you've seen basically, if you have questions to Datalog, I mean, I can do more complicated things here. I can do arithmetic, plus operations. I can do aggregates, like sum over all of this. I mean, it has like the typical, what you also have in SQL, the typical database functions, if you like to. And maybe I should, I mean, you can join over this by saying, for instance, that, well, yeah, I mean, I could join, I don't have this here. Let me show this to you if you're interested afterwards, because I don't want to go into too much detail, but it's obvious that you can add multiple clauses and it automatically joins. I don't know, who of you knows selmer? Okay, all right, great. Yeah, it's a nice templating language for Clojure that implements the Django style templating. So I'm just setting it up here with some small, so it provides some functions. I'm translating basically the units out of the data structure into LaTeX, because I happen to know it, and it looks really beautiful if you do it right. It's just stupidly complicated if you don't know how to set it up. But yeah, so this is just set up here, like what you would have to do. You can test this, like, okay, do I have the right kind of, in German it would be, you would need a semicolon there, sorry, a comma there, and yeah. Okay, and then here, and this is like the main function, and then I'm done. What I'm doing here is I want to render the PDF. So I want to call this with the client name, and it will then, with this first query function, it will get the entity ID of this customer. Then I will reuse this later, I think, somewhere in the pull expression. Yes, there, as client. So basically here, I will just fetch the whole client information. I already ask for the offer ID, which is an integer anyway, and here I do this recursive pulling of the whole nested data structure, and I ask for everything. And then I'm doing outside of Datascript, because I personally I've tried this a few times, but you do not have to, or Datalog. I'm not trying to calculate all the sums and aggregate values inside of Datalog, because it's not that helpful for this task. But if I have this recursive nested, or if I have this tree-like nested data structure, then I can just use the specter library and transform this into. So what I'm doing here is a sum for each. I multiply the effort with the effort price for each item, and then I do again a transformation in the next step and sum them up for each task group, and then I sum them up for the whole document, and then I have some taxing, and then I put all this together and I call selmer down here. So that's basically it. It's, I guess, it's a little bit long, but it's just the typical stuff. And then I have this here, and I can call this like this, and then I get the LaTeX output from the shell, which is not beautiful, but you can immediately see whether there's some error or not in the end. And then I have, so this is how we did it basically. In the company, we were doing pair programming, sitting in front of the beamer, having the PDF open, and then looking at the output, and at the same time working on the REPL, which was a pretty nice experience. And yeah, and that's like the final document, a little bit reduced, and then you have invoices generated, and it's like this very simple workflow. There could be more fancy Datalog examples. I guess I could have come up with them, but I wanted to really do something that was practical for everyday use. Okay.